And it'll, okay, it says we're live now, so we're officially recording.
Okay, cool.
Nobody's watching yet, though. You can see in the corner. Yeah. So right now we're still just kind of like jamming, and I'm just opening up the stream link. Hello to people who are trickling in. We're going to get started in just a second. I'll even turn my camera on so you can see me here. Hello. Just going to take a second to share the link in some places. But thank you for tuning in. Super stoked to have Mikerah, aka badcryptobitch on Twitter, joining us today to talk about a lot of cool stuff. Boom, boom, boom. Mikerah, I'm sorry, we forgot to tag you in the latest, the last post.
Oh, okay.
But oh, I just sent it in. Actually, sorry. Okay. Yeah, let's get started. I will let other people on the team retweet some things as needed. Mikerah, it's great to have you on here. How are you?
Tired.
I appreciate the honesty.
Does everybody say like, "Oh, I'm fine, I'm doing well"? Like crypto's like 24/7. How are you like not tired?
Yeah. I don't know. I'm always tired and not, but you know, when you wake up and you work in a fun, intellectually stimulating industry with cool people, it's hard to want to stop. But yeah, I wanted to thank you for coming on the show. I know your camera's broken, but that is okay because we're going to talk about a lot of cool stuff. And I just wanted to give my quick introduction to you and to what this stream is all about. So this is usually what we were calling our like community call slots for those of you who have been joining us on Discord for those. And this will be used for updates like that. But we also have a Monday alignment session stream every week, which is the core team, usually the founders, giving some updates and sharing their perspectives on the industry. Whereas Wednesdays are more community focused. And that includes inviting friends and partners within the broader like applied cryptography, ZK, and crypto space to come talk about cool stuff, share some knowledge with our listeners, hopefully give you all ideas for cool things you can build maybe on top of Aligned or on top of their projects using tools like ZK. And yeah, it is my pleasure to have Mikerah, who some of you may know on Twitter as @badcryptobitch. She has been working within the applied cryptography space for a long time, and I'm lucky to know her and to be able to learn from her. And yeah, Mikerah, welcome. I'll let you introduce yourself properly and all the different things you work on.
Well, hello. I'm usually like a background figure in the space, so it's like a bit weird to be a bit more at the forefront. But yeah, it's Mikerah. I am badcryptobitch on Twitter. I run a small consulting firm called Hashcloak, and I'm starting outside of Hashcloak, doing some more MPC VM research at a company called Stoffel Labs that's recently spun out of Hashcloak. So you'll be hearing a bit more of that today as well. And at Hashcloak, we spend a lot of time working with various teams in the space that you may know of on either like security auditing or on cryptography R&D. And yeah, my tweets are kind of like all over the place. Recently, people have said I'm like chaotic good. So it just goes from like my personal interest to like memes, which is why a lot of people know about me. And yeah, just a quick intro to what I do.
That's awesome. Thank you. I'm actually just dropping into the comments of the stream links to your account, Stoffel, and Hashcloak for folks who are interested in following along. Yeah, I think let's start with, well, I mean, there's so many things that I want to talk to you about, but let's start with the memes thing, because I think you are a little bit prolific for actually like creating memes around very technical topics. And like, I know you've talked about this before, but I would love to hear it again. Like, what's the what's the backstory there? Like, how did you become a ZK memer?
I mean, it kind of just like, so like around like a year ago almost, I was just like struggling to like talk about cryptography to like just people who weren't familiar with what I do. Right. So at Hashcloak, we're small, but we're growing. Like the kinds of clients we're getting has been like improving. We're like a 5-year-old company. So obviously, as part of that growth, you kind of have to like, you know, talk to people who aren't just my Twitter followers, but like people who work in crypto who may not be as technical as I am. And so memes are like a really good way to do that. And it just kind of started with topics that were sort of trendy at the time, right? So around a year or so ago, you were seeing like a lot of people announcing raises for like FHE companies. And in the midst of like, trying to justify FHE, they're like downplaying how it works, how it's deployed in practice. So like a lot of my initial memes were basically making fun of FHE, and in a more like technically poignant way. So people who like knew about FHE would like understand the memes, and then like people who didn't know about FHE would ideally learn something from the memes. Obviously, I wasn't thinking in this way when I was writing the memes. To me, they're just like funny. But like looking back at the memes, it was like, oh, actually, there's like a lesson here because the people who are technical agreed with the meme, and then the people who are non-technical learned something. And I think that's probably why initially they did like really well.
I wanted to interject and say that like I think that's how I also saw you or found out about you initially before I found out we were both in Toronto and actually met in person. It was this like I saw some people sharing memes you had made, and I really love it when I see a meme and I'm like, oh, I can see why this might be funny, but I don't understand the technical. Like I don't have the technical background to understand why it's actually funny, but maybe that's just other people in crypto aren't the same. Some people are. That is a way that I've dug deeper into topics because I'm like, I want to understand why this is funny. There's like also for people who know C-Node from Celestia, like I feel like he says a lot of very funny stuff that's like has very deep technical insights, and like that's how I kind of benchmark my progress in like learning about really like the nitty gritty within crypto. It's like, can I understand these very niche jokes that are talking about consensus mechanisms, So what about FHE though? Like what are the you just said people are raising money for FHE and downplaying it. And I feel like you have some interesting comments on that.
So this was about a year ago. I think now I've made enough memes that have like entered real life where like now the FHE teams are like a bit less grandiose. But at the time, a lot of it was like FHE is like very practical. You can run it today, or like they were sort of giving the impression that was the case. And we're saying like things like MPC, you can't really like use it in practice. It's slow, you have latency, which is sort of like, once you get to a certain point, when you get up like the privacy enhancing tech stack, generalizations are like less useful. It's like it becomes heavily like use case dependent. Obviously, like the marketing game is such that you need to like distill your message in such a way. But for me, it was like I can just make a meme out of this because it's hilarious.
So for people who don't for people who are listening who don't know what FHE is, do you have like a quick explanation of it? Because I don't, and I could try, but it'd be really bad. But like
I would probably just use like a black box analogy, right? So say you have like a machine and you can give this machine sort of like any functionality that you want to compute, right? Right. Say you're on Google and you don't want Google to like know the like what you're querying, right? You don't want Google to know your results. So like this black box say like, okay, you be my Google for me. And what you can do with this black box is give it any query, say something that's like taboo in your relevant culture. And then this black box will do some computation. So in the case of this Google example, usually some form of like advanced PageRank algorithm, and then spit you back like a list of results. And this black box in the midst of doing this doesn't know your query, and doesn't know like the final result of doesn't know the final list. It just knows to like output a list. So FHE is basically like a way to implement this black box. Is how
interesting. So yeah. FHE, fully homomorphic encryption. It's a way to do computation totally privately, where both the inputs and outputs are private, but you can still be assured that the computation happening is valid. It's verifiable.
Yeah. So in practice, there's been like a lot of work done in this over the past like 15 years. It's getting increasingly practical. It's being deployed in various ways, usually not like fully homomorphic encryption, but like things that are just like a rung below it, like partially homomorphic encryption. So
partially,
yeah,
it's like what's a rung below? Like partially, and you literally said it.
Like somewhat homomorphic encryption. Like there's different kinds of like categories.
Kind of homomorphic.
Yeah. But it's like it's getting better and it's getting to be more practical. But it's still for the use cases that we care about in the crypto space. It's not quite there yet. There's like still like a lot of work to do, right? So you're seeing like a lot of companies come out and building sort of EVM compatible FHE protocols, or like building hardware for FHE. So there's like a whole supply chain that's currently being built for FHE, which sort of implies that it's not ready. But yeah, people are kind of like optimistic about it after like, I think around this time, people were like investing a lot of zk as well. So it's like, what was like VCs were like, what was the next thing to invest after zk? And they went from zk to FHE directly. Ignored MPC and Ts in the midst of that.
Interesting.
And so like,
okay.
I was just making like, I remember like one of the first memes before like I went on my meme like binge was basically the NPC meme where you replace something in the NPC with like something else and it keeps on running. So like I remember making a meme that was like replace zk with FHE, and that went kind of viral. And so basically that's exactly what happened last year. It's like people were like shilling FHE all of a sudden on my Twitter feed, and like it was by people who like probably didn't use any of the current existing tooling for FHE or like were just like hyping it up. So it's like perplexing to see as somebody who's like tried to use this tool in the past, and even recently. At this point, that was like, wait, why is this going on? And a lot of my memes were kind of like making fun of that.
Yeah. So who are these people who are like shilling technology that they don't know anything about or don't have any experience about? Are these investors who are, putting money into companies developing this and they're trying to spread the word? Or are they just looking for engagement on Twitter because they know it's something that some like, deep insiders who do work on this might respond to? Like, do you have any theories there?
I mean, it's certainly VCs. Right. Because like normal people, like at least what I see on my feed and like who interacts, like the folks who interact with my tweets, tends to be like obvious shows, either like bots or like obvious shows. So like at that point, I kind of just like disregard it. And then everybody else is sort of like, you're right. How did FHE get all of this money all of a sudden? And then usually the answer is like VCs.
Yeah. Interesting. Okay, so I want to go back to something else you said, which was that FHE is not quite ready for a lot of the use cases that we care about within crypto and blockchains. What are some of those use cases? Because I've looked into it before, and I can probably come up with some hypothetical examples, but just to like help people kind of grok this a little better.
Right. So like the main areas where people are trying to use stuff like FHE in is in DeFi, right? So I don't know about like the folks on the stream, but like, the main area of crypto that has the most PMF, the most users is DeFi. So like rightfully so, you want to make sure that anything that you build sort of can like, make that pie grow larger, or like you're the unlock that makes the pie grow larger, right? So in this like privacy enhancing space, there's quite a few areas where FHE makes sense. In this DeFi space, there's quite a few areas where FHE makes sense. So there's stuff around like not private transactions per se, but like private trades. Because technically a trade is a transaction, so I didn't want to just use transaction in a general sense. So private trading, like dark pools, like that's one area that people are very excited about.
Okay.
that is like being shilled a lot recently.
Interesting.
Other areas are like auctions, right? Crypto is fundamentally just a bunch of auctions, or like, DeFi is fundamentally just a bunch of auction, right? Like every transaction you make, you're like paying a bid to some like block builder to like make sure that your transaction gets included, right? So auctions like another big use case.
Okay.
And then
So
like lending, stuff like that.
Yeah, a lot of things that would be default private in traditional finance, but is default public within crypto that people would like to, it requires some computation to happen, some smart contracts, different parties, but you want to now make that private. So you put it inside this FHE black box.
Yeah. There's some areas where like we kind of have close proxies to them in crypto. And so like the main distinction there is like the trust assumption. So like if you want the equivalent of a dark pool, then maybe you trust like a centralized exchange to be that dark pool for you, right? Because centralized exchanges don't hit the blockchain until you actually need to make a transaction. You can just like make all of your trades on like Coinbase, and your databases, obviously they make sure everything is consistent. And then once you actually need to make like a withdrawal of some sort or deposit of some sort, then you can see that deposit or withdrawal via like the Coinbase wallet, right? Or like one of their wallets because they have multiple. And in a sense, like for a lot of people, that's enough for their needs. And since like the public doesn't see what's going on Coinbase, it's kind of like a dark pool. But then the issue there is you're trusting Coinbase.
Yeah.
Right.
And the whole point is to remove these intermediaries, or at least a lot of people, myself included, believe that that's the whole point.
Right. Yeah, exactly. Or you can like use like private mempool services where like they hide the transaction. And then when the transaction has been settled and included, then you'll see the final transaction. And for some use cases, this looks like a dark pool, right? If anybody's like here is familiar with like MEV trading bots, that's how they kind of operate, is like via this like private mempools to make sure that their transactions get included quickly. And they can like take advantage of like arbitrage opportunities and stuff like that, or to protect against being sandwiched. So those, depending on like the use case, can also function as dark pools, but then you need to trust the sort of MEV pipeline, right? And that's also like kind of suboptimal depending on your preferences. So like using FHE for this is sort of like a big area that people are trying to build towards.
Yeah, that's cool. I'm not going to ask you to predict, or try to make a prediction about when this kind of stuff will be ready. But, you mentioned some MEV stuff that I think would be an interesting topic for us to dig into in the future, because the more I learn about it, the more I feel like there's a lot of stuff in the traditional financial services space that is just getting replicated here. Like order flow for people interested in MEV and transaction ordering would be very important. Like if you can be the sort of like, if you have privileged access to like the trades that people from a specific wallet are making, that is all of a sudden very valuable. And like privacy enhancing technologies can sort of remove that issue, or at least try to create incentives against that, but that's a bit of a digression. I wanted to also go back to something you said earlier, which was this meme where you're talking about how like MPC got completely skipped. Like people were talking about zk, it's like this hype thing, it's getting a ton of investment, TGEs are happening, and then it's like FHE, this is the next thing. But then MPC was kind of ignored, and I'd love for you to expand on that a little bit and maybe explain why that would be a good intermediate step between zk and FHE, and also just maybe give a short explanation of MPC, because I'm still trying to become more knowledgeable about the topic, and you are knowledgeable about the topic.
Right. I'd use the same analogy as before, right? Where like MPC is a way to implement this black box. You give it like a function that you want to compute, again, Google results, right? But then you keep the inputs private, and then the result is also private. You only know, the person doing like the query only knows like what they queried for and like what results are. So MPC is like a different way to implement this black box. But instead of having just like one machine, you have multiple machines doing this computation. So it's like an inherently like distributed version of this black box. I think a good way to think of it is, if you're familiar with like machine learning models, you'll know some of them, you can run them locally, but if you want to run it faster or take advantage of like some inherent structure in the ML model, then there's stuff like Apache Hadoop, Spark that help you run the model in like a more distributed fashion and scalable fashion. So MPC is kind of like doing that, but the inputs are private, and then the results are private.
Okay. So yeah, MPC is multi-party computation.
Exactly.
Right?
Yeah.
Okay, cool. So it's like multi-party, there's multiple parties doing this computation, which makes sense to me. But then why is it like easier in a sense than fully homomorphic encryption? Like you said, it can kind of do the same kind of thing. But like what's the difference there?
So I wouldn't say it's necessarily like easier. I would say that the tooling and like the practical deployments of it have just been there longer. The first real world deployment of MPC was like in 2008, the sugar-beet auction. It's like a famous case study in Denmark. Yeah, so like the sugar-beet farmers like do an auction every year, and there's like different parties that hold different kinds of data for this auction, and then typically before MPC, kind of had to just trust all the parties and not leak data and stuff like this. And so MPC was like, okay, let's have, the three parties. Like I think one of the party was like a neutral party, and then one party had like a bunch of data, and then like the farmers.
Okay.
And then
this is totally non-crypto. This is 2008, and we have sugar beet farmers who are auctioning off their like harvest to people who want to buy the sugar beets.
I think it was more than just the harvest. It was like before the harvest, like the equipment and like the supply chain data and stuff like this.
Interesting. Okay.
Like farming has like a large like, it's like a lot of like farming is like way more involved than people give it credit for. But in any case, like MPC was like a solution for this, and so like it took like 30 minutes to run the auction back then, but it worked. And then I think nowadays they still use probably not the same infrastructure as back then, but MPC is still used for these kinds of use cases in Denmark and in other places in Europe.
Cool.
And so like it's just been around longer. So obviously there's been like advances. And like if you sort of go down the MPC rabbit hole, as I did a few years ago, you'll see there's actually like a lot of practical code for running MPC. Right.
Like
so
implementations of these cryptographic primitives that can actually run on a computer.
Right, exactly. Right, so like a lot of the early implementations, same thing that happened with zk, right? Like a lot of the early implementations were like, you need to like understand this weird API, you need to understand circuits, right? And then the way you encode the circuits or describe the circuits is like dependent on, your computation and all of this, right? You basically have to be an expert to like understand this stuff. But like around like the turn of like 2010s, right? There's been more work in doing like more like VM style things for MPC, and then that work has been like ongoing for like the past 10, 15 years. But it's pretty prevalent outside of crypto, like in regular cryptography. People use this tooling. Yeah, like people use this tooling for like benchmarks, for use cases. The tooling is optimized for like academics.
I see.
Right.
And I guess the idea is you want to be assured that like some computation is happening properly and privately, and you have multiple parties involved that all need to agree, like sort of come to consensus on this.
Right. So yeah, like the tooling is sort of there to use this stuff. But it's not obvious if you're not into it. And I guess that's probably what happened in crypto, right? A lot of it's like very hype driven. So like if like nobody's there to like be a voice, or I guess doesn't have connections to like the people who do have a voice, you end up just like skipping sort of like the obvious answer.
Interesting.
So I think that's probably why you went from like zk to FHE. It also doesn't help that there were attempts in the past to bring MPC to crypto, and they kind of failed. And MPC here, I'm meaning like general purpose MPC, right? So by general purpose, I mean like this kind of VM style where you just like write whatever you want, and you're able to like execute that in an MPC fashion, right? Like going back to this black box analogy, you're able to like specify you want the black box to do, and then just have it do it. The main form of MPC that people think of and use in the space is like threshold signatures, which is just like one specific instantiation of MPC. So like to recap, threshold signatures are used for like wallets. You split a signature into shares at a high level. Like again, some of these things are different depending on the specific use case. But at a high level, you split like a signature into shares, and then depending on the implementation, your wallet has like one share, and then you have like the other two shares. And then in order to like sign a transaction, you need to make sure that everybody's online to sign the transaction. Yeah, that's basically like how people know MPC in the space, and that has huge PMF. We just saw Privy announce a Series B round. Congrats to them.
I saw that today. Yeah. What did they say how much that round was? Because I didn't see it in the announcement.
I think it's I saw on like the Twitter sort of trending, it says 15 million.
Okay.
And then there's like a Forbes article or Fortune article about the actual amount. I didn't click on it. I just saw like the thread.
I didn't see it in the thread, so I wasn't sure. But yeah, it's okay. This is I wanted to zoom into this a little bit because my understanding was that MPC, or rather a subcategory of MPC, threshold signing, threshold encryption, threshold signing, same thing, or
they're different.
They're different. Okay, so threshold signing. Let me try to run this back at you just to make sure I understand, because it seems like a good analogy is almost like multi-sigs. Like you have a wallet, and the only way for this wallet to sign a transaction and actually do something is you need all of the different entities that have a piece. You said a share of the signature. They all have to sign together to be able to actually do the transaction, right? And this is
right.
Is that correct?
I mean, it's like policies you can put where you can have like 2 out of 3 shares and like stuff like that.
And I guess the idea is then you could have like recovery for your wallets or extra security, or like I'm thinking of it like a multi-sig, but I don't know if that's an oversimplification or really captures why this is important.
So multi-sigs, I think this is like a very common misconception. Multi-sigs are like you need X amount of signatures, of like distinct signatures, to then perform an action, right? Usually the action is like, send money or something like this. Whereas like threshold signatures are you're trying to construct one signature.
Okay.
So like where the policy is applied is like different. So yeah, multi-sigs is like you need a minimum of signatures from different parties in order to execute an action. Whereas like for threshold wallets, it's typically for specific like one signature. Like I'm the party who controls like the wallet, but like for whatever reason, like I don't want to deal with like seed phrases or whatever it is. I can use MPC to like control my wallet, and then you sort of either, again, depending on the implementation, you either trust some other service with the other share, and then you keep one share for your own recovery. But then when you need to like sign a transaction, you're able to use one share, and then the company has the other share, and you're able to like sign this transaction. Combine the signature for the transaction, and then execute that.
Okay. Cool. So I think I'm sort of following this, and I remember you tweeting something recently from maybe the Stoffel account or your personal account about MPC virtual machines, and like something I've been digging into a lot recently is zkVMs, and we've talked about this a bunch on recent streams. We're actually going to be, I think, publishing a thread later today talking about our zk benchmarks zkVM benchmarking effort. So I'd love to hear more about. Well, I think I want to hear about Stoffel. Like you've mentioned it to me before, but this is your new startup. You're building products. It's focused on MPC, just based on the name. I'm inferring that. So I want to hear about that and like this MPC-VM idea, because it's something I actually haven't heard of beyond just something you tweeted.
Right. Yeah. So going back to the conversation of like the advances of MPC since like 2010, like regular cryptographers, the ones that don't do like magical internet money stuff, they've been like working on making MPC more accessible through building VMs. So like there's been work for like the past 10, 15 years in this direction. And basically what this means is think of like any VM that you've used, right? Just like regular programming languages, where you have a language, you're able to like write anything in it, and then it compiles down to some VM bytecode. So this is like the exact same sort of flow that cryptographers have been working towards for a long time for MPC. But instead of like having it just run locally, it runs in a distributed network, right? So like a good example is like the JVM. I don't know how the people on this call are, like what their programming experiences are, but for a long time, like Java was like you were able to like run this on in your browser. You're able to run this on your phone if you have Android. You're able to run this on like smart cards, and that's because you had like the JVM, and it was meant to be like you run it once, you can execute it anywhere, and so that's why VMs are so powerful, because you don't need to be married to like the fundamental architecture of like the machine your code is running on, right? But then like the trade-off is that it tends to be slower. You have to like do all of this like compilation stuff, right? Because you're like virtualizing an actual machine,
Yeah.
right? And so, but then the trade-off is like it's super easy for anybody to like write code and have it execute everywhere. So in a way, like a lot of like modern languages sort of have adopted a very similar, architecture for how they deploy things, right? Like another good example is JavaScript. Like it runs in your browser, and then via tools like Node, it runs locally as well. So like this has just been sort of an overarching like computer science trend for longer than I've been born, basically. Both of us probably actually. So right, like MPC researchers like sort of just followed that overall trend, and have been like building towards that for forever, and still building towards it today. So like our work at Stoffel Labs is like we're trying to make this just more accessible for like normal developers, basically.
Okay.
Yeah.
Cool. I love that. So yeah, I wanted to also just like try to repeat this back to you and make sure I'm understanding it, because like VMs, virtual machines, for people who might be confused, like I'm going to come back to the example of zkVMs because it's what we've been talking about a lot lately. Right. And we have this zkVM, so it's a virtual machine where you can run some arbitrary code written in Rust maybe, or another language that's supported, and then this will inside the VM get like compiled and executed, but it actually generates a proof at the end, which can then be verified. So whatever computation happens inside the VM is completely verifiable, and that's why it's like a zero knowledge virtual machine. So
even though it's a bit of a misnomer, because like the inputs are not necessarily private to the VM.
It's a validity. It's a validity VM, I guess.
Yeah.
VVM, but nobody's calling them validity rollups either. So I think people have given up on that and just are leaning into the ZK branding, which I think is fine. ZK TLS seems like it's actually MPC TLS, but it's okay.
I tweeted about that, and like people were not happy about that tweet. But I was like, it's a bad name.
Yeah, that's something that Hirsch, the founder of Opacity, one of the co-founders, Euler Lagrange on Twitter, on Farcaster, if people know him, he was like, zkTLS is a misnomer, but just like chill, like don't complain. We're increasing the brand equity of ZK. Be happy. So with come back to this MPC-VM idea, because I'm still trying to wrap my head around it. Like, if you can use the zkVM example as like a starting point, what is it that, like, after computation happens in the VM, what is the end result?
So it's more about like the actual computation itself. The end result is just
Output some
just output like what you
data.
intended.
Yeah.
It's more about like what does the VM give you, right? So going back to the zkVM example, right, like normal VMs, they just give you an output, right? Like JVM, Java engines in browsers, they just give you an output, but they're all optimized for like a specific like feature or environment, right? So Java wasn't specifically optimized for a specific environment. It was optimized to run everywhere, right? That was like the campaign at the time, right? Write once, execute everywhere. So if you have an Android phone, you have like a Java VM. Well, not these days, but at one point you had like a Java VM. Now it's like a bit more complicated. If you have like older smart cards at like larger companies, then that should be, not should, but some of them run JVM.
Did you say smart cars, like a vehicle?
Cards, like
cards. Okay.
Yeah. At one point on the internet, before like JavaScript took over, you had these Java applets that allowed you to like do more complicated things, right? Like physics simulations, stuff like that, right? So like the JVM was like sort of like optimized to just be everywhere,
like
right?
Run the same code on every device,
right? But it doesn't give you like a proof once you run it.
Yeah.
Right, exactly. Whereas for zkVMs, it gives you a proof, right? So it may not be optimized to run everywhere, right? Because the VM itself, it needs a prover, and the prover is like computationally expensive. So like it doesn't have a slogan of like write once, execute everywhere, because you need to execute at least once on a beefy machine. Well, for current zkVMs. But then the nice part of that is that like beefy computation only needed to be done once. You get like a proof at the end of the computation alongside like the actual output, right?
You got a proof that can be verified and doesn't need to be re-executed to confirm that it was done properly.
Right, exactly. So the VM here like gives you like an extra guarantee that like other VMs in general, like in just general programming, don't provide. Right. So like the point of VMs is like, obviously you want some form of like general purpose computation, but you also want to provide like an actual like unique feature that the VM provides, right? So going back to like the examples, JVM, you can run it anywhere. zkVMs, you get a proof. And then MPC-VMs, you get an inherently distributed computation, right? So like the internet is fundamentally distributed. The computations that we do on the internet, most of them are distributed. And so MPC gives you like something that just computes a function in a distributed manner. Right. So you can kind of, so that's the way I would like explain an MPC-VM and what it gives you.
It's
stuff
it's,
like
it's a VM that by default is like it's going to be distributed over multiple actors, multiple computers, and then you can, I guess, tune how many of those and all the details. But so it's like a distributed VM.
Yeah, I think that's like a good way to put it. Yeah. Obviously, like things like verifiability, you can always add on. But like fundamentally, it's like this distributed nature of compute that MPC gives, and then like the nice features you get is like the nodes don't know your inputs, and it doesn't know your output. Right.
Interesting. That sounds very powerful, because the first thing that I thought of when you said, distributed compute, I'm like, oh, so we're talking about Ethereum. We have a bunch of nodes that are all doing computation, but it's not really the same. They're all just doing the same computation, and agreeing that the state has transitioned according to the rules of the computation. Whereas here, they're actually doing the computation together on the same like instance, sort of like
instance in terms of like time
or like this. Yeah, that's kind of what I meant. Yeah, like, is it actually like all synchronously being computed, or this? It's just that there is some time frame where they all need to do the computation together or contribute to it. I mean, maybe we're getting a little too deep into the weeds here, but
like it's meant to be ran together.
Okay, cool.
Yeah.
Cool.
Like most like the high level like definition tends to be like, yeah, all the nodes run together. Obviously you can get into the weeds, like there's different variants of MPC, and then like people will argue at that point, is that MPC or is that just FHE? And like that's just like bike shedding.
Yeah.
That's just like another meme for another. I mean, I think I've made memes about it, but it's just like at that point it's kind of like whatever. But then yeah, you can get into like different forms of MPC and what kind of like online guarantees you have. But like the high level like definition tends to be like everybody just runs the computation together. Yeah.
Cool.
Yeah, so going back to the EVM as an example of like a
Yeah.
VM that gives you some feature, right? Right. Blockchains are deterministic systems. Most VMs are like, you know, you can run all sorts of things, right? Because they tend to simulate an actual computer. But blockchains, you can't really do that. So the EVM is like optimized for like being deterministic, and that like every node can ensure that they've done the same computation, right, without like any external feedback, except for like, you know, the initial block download, right? So like the EVM is like also like a VM with a feature, and that's why it exists. And that feature is like non-trivial. Like determinism in computer science is like a huge topic. We don't talk about it enough. But yeah, you know, VMs are like fun to play with because you can really optimize it for whatever key feature you want, right? Have it run everywhere, have it like provide proofs of computation, have it enforce determinism, have it like execute over multiple computers. So yeah.
Yeah. And ultimately just make it easier for people to write software using these different tools. I keep coming back to the zkVM example because it's where I've been spending a lot of time sort of reading and learning lately. And it's like, you don't have to write circuits anymore to generate a proof of computation. You can use normal code and run it inside a zkVM. So with MPC, you don't need to go for any crazy MPC implementation here. That's more complicated. You can just use your normal programming language inside the MPC-VM.
Right. Yeah. Or like any sort of front end that like targets the VM, you can have it work.
Cool. That's super fascinating. So with Stoffel, I guess this is technology that you are actively working on developing.
Yeah, we're working on this at Stoffel. We started at Hashcloak, but we needed more resources, and Hashcloak does consulting. So we decided to spin it out, kind of similar to like how Aligned exists, because like, Lambda class does like consulting, and then they spin out companies. So yeah, we did the same here. So Stoffel Labs is working on MPC-VMs.
Cool. The Venture Studio arc.
We're not. I don't know if I want to do Venture Studios or whatever. But it just like this needed to exist. So
it's your first product company out of like the consulting company.
Yeah,
which is
like it's just MPC-VMs. Like I think are like the future of just the internet. Yeah, like kind of how like people think like zkVMs will be everywhere. I think like MPC-VMs will be everywhere in the same way. Right? The internet is like inherently distributed. Everything you're doing these days is like inherently distributed. Unfortunately, we have to like trust, you know, these like large tech companies. And so like MPC-VMs are like a strict improvement over like the current status quo. So it just needed to be done in its separate company with like dedicated resources.
Yeah, that's beautiful. I mean that's a big part of what drew me to crypto in the first place. It's the ability to do things peer-to-peer over the internet, without intermediaries, you know, without needing to trust third parties, and having more sovereignty over our assets and data and digital relationships. So I learned a lot already, and that's very cool. I could see the value in wanting to be able to do private distributed computation over some data with peers and not having to give that up to, you know, some big server somewhere else. Yes, that means running it on your own computer and having the necessary resources. And like you said, VMs.
Even if you had like Google run MPC networks internally for like the various functions that they use, like that's still a strict like improvement over like the current state of Google, right? Because like now they don't need to store your data unencrypted, right? Right now they just store everything, right? So if you can like recreate Google, but with MPC and these other technologies that people are building, then you get like a strict improvement, even if Google is still running the infrastructure. Right?
So when you say
now
improvement,
they don't need to store. Like,
do you mean
data.
like in terms of like improvement in terms of less data storage costs or less, I don't know, risk they're taking on by custodying people's data? Or
Yeah,
something
custody
else?
of data and data costs, right? Data is becoming increasingly like a liability for Web 2, right? Hacks, all over this stuff. Increasing scrutiny from various regulators, right? So ZK, MPC, FHE, Ts, like all the 3-letter acronyms are becoming increasingly important.
3-letter PETs.
Right.
Yeah.
They're becoming increasingly important. So even if like Google ran this stuff, maybe it's like not like super distributed because like Google controls like the node operations, but fundamentally the nodes are still distributed, like doing some compute over those nodes. I would say this is like a strict like improvement over what Google is currently doing.
Yeah.
So
That's
that's why I just think like even if like you might have your opinions about like general purpose versus special purpose and all of this stuff, or like versus like multiple nodes versus running on one server or whatever. I think what everybody's like building in the space in this like specific like cryptography space, if it were to be adopted, would be like a strict improvement over like currently deployed systems on the internet.
That's very cool. I'm incredibly bullish on this concept and am very excited to go down some rabbit holes trying to understand this in more detail and thinking of cool use cases. So Mikerah, I mean, we've been on for 45 minutes and I'm happy to keep talking as long as you do. I don't want to keep you too long. And I think I could ask you questions for hours for sure.
Does the audience have questions?
I haven't seen anything in the chat. And so I mean, I guess nothing now. I can like take a quick look at Telegram and Discord. Ask. Like, hey, I mean, if people have questions, if you're listening in, feel free to drop them in the chat. But I mean, like I guess I have two questions for you. One is, if you want to talk about it, like I think something cool that I saw recently that Hashcloak has done is you guys got a grant, like a Noir research grant to do some cool ZK stuff, and I think that'd be cool to hear about the Semaphore implementation in Noir. But the other thing I just wanted to ask about is more stuff about Stoffel, because I'm super excited about this. Like, I saw that you're building in the open, which I love. We're also like open source from day one, something we think is very important at Aligned. But yeah, is there a repo people can check out, or demos, or example use cases already, or maybe a timeline for when people can expect these sorts of things?
Very soon.
Very soon. Okay. Soon trademark.
Yeah, very soon. No, but like it's gonna be soon trademark, but then in public, and then the trademark you'll see when it ends, right, at some point. No, but honestly, like very soon in terms of like announcements and all of that. So yeah, go follow on Twitter. We have a Telegram group. We have Discord. And then for Hashcloak, we got a grant for some more Noir work. We got the previous like NRG 2 grant as well, that concluded at NoirCon in East Denver.
Yeah, I saw you had a report on your work from that.
Yeah, and that was really cool because like we got to play with other MPC toolings at Hashcloak. Like Hashcloak, we're familiar with like MP Speed, Scale Mamba, and stuff like that, but Noir is new. So you wanted like more hands-on experience with that. So that was like really fun. TCO folks are really great people. And that was like a really fun project because we basically ran logistic regression training in an MPC network, right? The logistic regression like training is just SGD, and that was run in MPC network.
That's like a machine learning algorithm, right? Like a gradient descent.
Yeah, stochastic gradient descent, and then the result was like we got a result. We were able to like prove the execution of it without having to like redo the MPC computation, right? So like that was really cool. The benchmarks, like they look kind of rough, but it can only get better, right? And so we're like very just optimistic about the tech in general. Not just myself, but like Hashcloak, the company, like that's a bet that we're going to be doing like more MPC stuff in terms of like helping clients and integrate MPC into what they're building. And then distinctly at Stoffel Labs, we're also like bullish on MPC and where it will fit everywhere. And I should also note that they're separate companies, they're independent. In the same way that Aligned and Lambda Class are independent. Very similar concepts.
But, collaborating and sharing knowledge, right? To some extent, I guess. Actually, I don't know. I'm not sure if that's the case with you guys, if you have to keep it completely separate for business purposes. But Mikerah, super, super cool stuff. I mean, I learned a lot over the last 50 minutes. I think I have a much stronger understanding of what MPC is and what an MPC-VM is for sure. That's something I really had no idea about, and I'm super excited to learn more about. So yeah, I don't know if you have any more closing words. Thank you for your time. I had a lot of fun. I guess I want to repeat what you said. To anybody listening, follow Stoffel Labs, follow Mikerah at badcryptobitch on Twitter, follow Hashcloak. And I guess if people are looking for help with any applied cryptography stuff, MPC work, they should reach out to you via Twitter, or
we also do zk work as well. I should mention that. That's our bread and butter, actually. The zk work is our bread and butter. The MPC stuff is we're trying to enter it more.
Okay. Cool. Good to know. Yeah. So if you're listening and you need some help with zk or MPC, hit her up. Cool.
So is this when it ends, or is there
no. There aren't any questions that have come in from the chat. In total, we've had 471 people tune in, and I guess I'll just say, if you're listening, if you're watching this after, this is going to be on YouTube. The recording will be available on Twitter as well. If you have feedback or comments or questions, I'm sure you can find Mikerah on Twitter. But also, if you have feedback about what kind of guests you'd like on these streams, please reach out to us. I'm easily findable in the Aligned Discord and Telegram group. We're doing these to help educate people on the different tools that are available within zk, applied cryptography, crypto, so more people can understand how to use this technology to build cool new products and services. That's what we're trying to do at Aligned as well. We just want to highlight people within the community, friends, people building cool stuff. When we do hackathons and we have people build cool things in our hackathons, we like to bring them on as well. If you have ideas for guests or topics you would like us to explore in more detail, please reach out, let us know. And with that, Mikerah, thank you again for joining us. Thank you for the time and for sharing your knowledge. This was a lot of fun for me. And
thank you for having me. I didn't think it'd be so casual. I was actually very nervous.
Nervous? Me? Why would you be nervous to talk to me?
Well, I usually just tweet. I'm just good at tweeting. I'm not a public-facing figure. People are always oh, you criticize so much, but you don't build. But I'm a background figure, right?
Yeah.
I'm a consultant. I help teams. So
but now you're going founder mode, getting out there in public.
I'm just not used to it, basically.
Happy to give you a platform. And I invited you on because I've spoken to you a bunch and I know you're super knowledgeable, and I've learned a lot just in our little conversations here and there at conferences. So I was fully confident that you would do great, and you did. But okay, I'm gonna end the stream now. Thank you everyone for tuning in, and see you next time.
Thank you. Bye.
Okay.